Welcome back. We are still in even and odds. This is activity 1.2, and we are continuing to talk about Joel and Haram and their two six-sided number cubes. All right, it says, recall the game that Joel and Haram are playing with two six-sided number cubes. Now you will calculate the theoretical probability of each sum. So we just did experimental. Now we're going to calculate the theoretical with these two dice. By playing the game in the experiment, you can see that this game has a non-uniform probability model. However, calculating the theoretical probabilities of each outcome is difficult without knowing them all. One method to determine the probabilities of the outcome is to make a list of all possible outcomes. Number one, how many different possibilities are there when rolling two six-sided number cubes? We will answer that in a sec. When there are a large number of possible outcomes, an array like the one you used before, let me highlight that word. An array like used before, remember this is an array, is useful in organizing the outcomes. The entries in the array should be related to the experiment. Number 2 says the array shown has two numbers filled in, 2 and 7. Letter A says, what does the 2 represent in the array? Number 7, or B says, what does the 7 represent in the array? So as you can see, here's that 2, here's that 7. And then number 3 says, complete the array. How many different possibilities are in the number array? So in a second, we're going to pause because I would like you to, and maybe highlight these just like I am. I want you to complete question number 4, question number 3, question number 2A and B, and also question number 1 on your own. So main thing I want you to do now is to fill in this array first and then answer those questions. So you're answering question 1, question 2, then 3, you're completing the array, and then question 4, how many different possibilities are in the array. I'm going to help you get started. So for this, when you fill it in, you're looking at the first number cube and the second number cube off to the side. So my first number cube, if I roll a 1, drawing. If I roll a 1, and my second number cube, I also roll a 1. Well, when I'm adding these together, because remember we're finding the sum, when I add those together, then I get a 2. So that just kind of helps you with 2A right there. And you're going to continue filling this in. So if I get a 2 and a 1, that's going to give me 3. If I get a 3 and 1, that's giving me 4. 4 and 1, that's giving me 5. 5 and 1 is 6. 6 plus 1 gives me 7. And you're just filling it in that way. So 6 and 6 would also give me 12. Just like that. Okay, go ahead and answer those questions, 1 through 4 on your own and with a partner. Set your timer for about 3 to 4 minutes max. 3 to 4 minutes max. Pause here. Alrighty, here's our completed array with all of our outcomes listed. Now let's answer these questions. So question number 1 says, how many different possibilities are there when rolling two six-sided number cubes? Well, as you can see, these are all of the different possibilities. If I count all of them up, I would get a total of 36 outcomes, 36 possible outcomes. And also a quick way to get that is by multiplying the number of outcomes on each cube. So if one dice has a total of 6 outcomes and another dice has a total of 6 outcomes, I can multiply that to determine my total number of outcomes. Okay, let's go ahead and continue to question 2A. It says, what does a 2 represent? Well, I kind of already explained it earlier, but it represents when both number cubes, show a 1, and 1 and 1 equal the sum of 2. And the same thing with number 7. I can clearly see that This first number cube landed on a 3, and the second number cube landed on a 4, and 4 plus 3 gives us 7. And there's my answer written. Pretty self-explanatory. Number 3, we completed the array. If you don't have those numbers in, go ahead and get them in now. Pretty easy to write in a row. 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, across and down. And number 4 says how many different possibilities are in the number array? Well, just by looking at our array and also getting our total amount of outcomes, we can determine there are 36 different possible outcomes. And the reason there are 36 is because, just like we explained earlier, I can get a 7 multiple ways, yes, but even those multiple ways is a different outcome. So I can roll a 5 and a 2, that's an outcome, and get 7. And I can also roll a 4 and a 3, that's a separate outcome, but I still get a 7. All right, number 5, it says, does it appear that the list of all possibilities when rolling 2 number cubes has the same number of possibilities as the number array? To save us time, because we didn't write this list out completely, but to save us time, I'm going to go ahead and give us that answer. Yes, the list and the array show all possible outcomes, but the easiest way or the easier way to organize all of your outcomes would be in this array model and not a list, or compared to the list. The array would be more easier to organize. Okay, number 6, it says, using the array, determine the number of times each sum appears and the theoretical probability in fraction form of each sum. Record your answers in the table. Is there an equally likely chance for each outcome to occur from rolling 2 number cubes according to the theoretical probabilities? And number 8 says, according to the theoretical probabilities, who should win the game? Explain your reasoning. All right, so I'm going to get us started with this probability outcome so that you can see how we would use an array to help organize those outcomes. So let's go ahead and fill in this table. So the outcomes were 2 through 12. So go ahead and annotate that. Drawing. There we go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And now we have to count the number of times that those showed. So I'm going to go back up to my array and I'm going to look for 2. Here is a 2. Is there another 2? No, there is not. So I'm going to then annotate that it only showed up 1 time. And now for my 3. I see 3. I see 3. Do I see any other 3s? Nope. So I can see a 3 showed up 2 times. All right, I'm going to pause here because I want you all to do the rest. I'm going to show you how you would calculate that probability. So being that our total outcomes, there were 36, all of our numbers are out of 36. So 1 out of 36 is our probability. Alrighty, so like I said, I'm going to pause here. You're completing the rest of this theoretical outcome table, and you are answering questions. Let me highlight them. 6, 7, and also 8, you are answering who should win the game. All right, set your timer for about 4 minutes to get this completed. 4 minutes, pause here. Alrighty, let's compare answers. So here is what your completed table should look like. So now that we've gotten number 6 out of the way, let's go ahead and answer questions number 7 and 8. So number 7 says, is there an equally likely chance for each outcome to occur from rolling 2 number cubes according to the theoretical probabilities? So according to the theoretical probabilities, what we just calculated, the answer is, what do you think? Is there an equally likely chance? You should have gotten, no, there isn't, because each of those outcomes have a different probability. So if you look at it carefully, with number 2, 3 through 5, it starts off with 1 out of 36. Then 3 has a 2 out of 20 out of 36 chance. To roll a 4 has a 3 out of 36 probability, and then so forth. The one with the highest probability is 7 because it has a 6 out of 36% chance. And then the ones with the lowest are 2 and 12. So the answer to this, of course, would be no, they do not. And number 8, according to the theoretical probabilities, who should win the game? So let's look. Let's calculate our even sums and our odd sums. So I'm going to use blue for Joel since he's our even. So rolling a 2 outcome is even, a 4 is even, a 6, an 8, a 10, and a 12 is even. So according to the theoretical, let's see, Joel, let me get my pen. Joel should have a 1, 2, 3, 4, 9, 14, 15, 16, 17, 18 out of 36 chance. And Haram, let's do orange for Haram to highlight those. So he's got a 2, or excuse me, odd is 3, odd outcome 5, the odd outcome 7, the odd outcome 9, and 11. Let's add those up. That gives us 2, 6, 12, 13, 14, 15, 16, 17, 18. So Haram has an 18 out of 36% chance. So now looking at these, is it easy, to determine who will most likely win? No, because as we can see, they both have the same chance of winning here. Okay, let's move forward. So number 9, did the experimental probability of your experiment in the previous activity match the theoretical probability of the game? If not, why do you think the results of the experimental and theoretical probabilities were different? So let's go back and remind ourselves of what that experimental probability got us. So in the last activity, we saw from our experiment that Haram won with those odd numbers. Okay, so he had 16 points and Joel had 9 of the points out of 25, or 16 out of 25 probability. In our theoretical, they both had the same chance of winning. So now let's think about why those are different. So the first part of this question asks, did they match? No, they did not match. Reason being, well, with experimental, spelled that wrong. With experimental probability, any result can occur. And with theoretical, spelled that wrong, I'll fix it in a second. It is just a prediction. Alrighty. Number 10, it says calculate the percent error between the experimental and theoretical probabilities of Haram winning the game. Now, this the percent error we went over in the last activity. So I'm going to remind you what that formula is and help you get started with that. So here is our formula, and let's go ahead and fill in our values. So the probability that was experimental for Haram winning the game was 16 out of 25 minus the theoretical, which we got was 18 out of 36, and all of that over the theoretical, which was 18 over 36, and then multiply all of this times 100. Now, I also am going to simplify this 18 over 36 because that'll be an easy number to work with. I know that 18 over 36 simplifies to be 1/2. So I'm going to change that to 1/2. Might be an easier number to work with. Now, if you're comfortable working this out on your own, go ahead and give it a try. If not, I'm just going to kind of explain what I would do in this situation. So remember, to subtract, we have to have common denominators. So 2 and 25, I'm just going to scale up both of these up, and I'm going to go to 50. Alrighty, I paused and I skipped a couple steps, so I'm not even sure where I paused at, but here's your final answer. So when you then subtract 32 minus 25 fiftieths, you get 7 fiftieths, and you divide 7 fiftieths divided by 25 fiftieths, which is essentially 7 divided by 25, and then turning that into a percentage by multiplying by 100, you get 28%. So we can see that the experimental probability of Haram winning was 28% more than what we predicted with our theoretical. All right, question 11. It says, oh, I'm sorry, let me back up. If you need a couple seconds to get this down, go ahead and do that because we are about to move on. Alrighty, question 11 says, calculate each probability when rolling two number cubes and summing the resulting numbers. Explain your calculations. So now we're going to use our array to actually find some probability. So 11A, 11B, and 11C. So 11A says the probability of it being a prime number. So remember, a prime number is a number that can only be divided by 1 in itself. So let's mark this up in, let's say, pink. Let's do this one together. Then you guys are going to do B and C on your own. So prime numbers, we've got prime number is 2. So using 1 out of 36 as a probability. Another prime number is 3. Another prime number is 5. Another prime is 7. Another prime number would be not 9, not 10, 11, and not 12. So now let's add those calculations or add those probabilities. So we've got 1 plus 2, 3 plus, 1 plus 2, 3 plus 4 gives you 7, plus 6 gives you 13, plus 2 more gives you 14, 15. So we just calculated that manually in our heads, and we've got 15 out of 36 total outcomes would be the probability for a prime number. All right, so now you're going to do one for, or calculate the probability for numbers that are greater than 7 and the probability of rolling a 1. Now remember, you can also not only look at your probability table, but you can also look at your array and count up how many. So for example, count exactly how many prime numbers you had. So we had one prime number, we've got 2 3s right here, we've got several 5s right here. That's just one way to also calculate that number. Okay, I'm going to pause this here. Set your timer for about 2 minutes max to knock out these probabilities for number 11. Pause here. All right, let's compare answers. For B, you should have gotten 15 out of 36 for the probability of rolling numbers greater than 7. And then the probability of rolling a 1, a sum of 1, would be 0 out of 36 because our smallest outcome is 2 when you roll two ones. Remember, we have 2 number cubes. All right, let's move on. Number 12, it says, if the number cubes are tossed 180 times, how many times do you predict the following sums would occur? So now we're getting into that proportional reasoning, which we did with, let me go back. Sorry, which we did with our proportions in the last activity. So let me show you how this would happen. So it says, how many times do you predict the following sums would occur? So a 1, we already know that would probably happen 0 times. So let's just go ahead and put 0% because we can't roll a 1, but we can roll a 4. So to get the prediction of rolling a 4, we need to first find that probability and then put that number equal to x over 180. So that probability was 3 out of 36. And now we need to figure out what this x represents. I can tell you right now that 36 times 5 is going to give you 180. So what we do at the bottom, we must do to the top. So I'm also going to do times 5 to the top, which means this probability would be 15 out of 180. So the chances of rolling a 4 would be 15 times out of 180 rolls. All right, using that as an example, I want you to go ahead and complete now questions number 9. So what's the prediction for rolling a 9 out of 180 times? For rolling a 10, what's that probability? An 11 and a prime number. Go ahead and take about 3 minutes here, 3 minutes max. If you don't finish all of them in 3 minutes, that's okay. Try to shoot for at least one or two. Okay, 3 minutes on the clock starting now. Pause here. Alrighty, let's check our answers. So for C, you should have gotten 20. So the probability or the predicted amount of times it would land on 9, or the sum would be 9 out of 180 times is 20. For D, you should have gotten 15. For E, 12, you should have gotten 5 times. And for your prime number, we just used the probability that we found here, 15 out of 36. You should have gotten 75 times is the prediction. Take a couple seconds, get this copied if you need it. If you don't have all of it, it is okay. At least if you have one or two, that should be perfect. All right, and number 13, to close us out. It says Kelsey claims that the probability of getting a sum of 4 when rolling 2 number cubes should be 1 out of 11 since there are 4 possible outcomes. Is Kelsey correct? If not, how could you convince Kelsey that her thinking is incorrect? So I want you to think about this, write your answer, talk about it with a neighbor, but take no more than about 2 minutes and then write your answer and we'll come back and compare. So 2 minutes on the clock, talk with the neighbor or with Casper, write your response, and then we'll come back. Pause here, 2 minutes. Alrighty, let's compare. So I wrote, Kelsey is not correct. Not all outcomes have the same probability of being rolled. So for an example, 2 plus 2 is equal to 4. 3 plus 1 is equal to 4, yes, but 3 plus 4 is equal to 7. 6 plus 1 is equal to 7. And 5 plus 2 is also equal to 7. So just in that example, you can see that there's more of a chance of rolling a 7 than there is rolling a 4. So they are not all equally likely. Alrighty, and that concludes this activity. I will see you in the next video.